Introduction. Good afternoon, everyone. My name is Christian and my working partner are Laura Alvarez, Camilo Malaver, Sofia Ortiz, and Brian Camacho. So, we will show you a lab practice about kinds of link of carbon element and hydrogen element. So, hypothesis. We can see that there are three kinds of link, which are simple link, double link, and triple link. Summary. Exist three kinds of link between elements of periodic table, which are simple link, double link, and triple link. In this video you will watch those kind of links and as they will be intertwined with carbon element and hydrogen element. Let's us begin. Problematization. What kinds of link exist and which can form carbon element and hydrogen element?
General objective. Identification is one of the links according to a structure and principal description. Specific objectives. Number 1. Understand of empirical manner the chemical interaction between the carbono and hydrogen through the construction of models. Number 2. Interact in a didactic way with archetypes of compounds such as graphene and graphite.
Tutorials. From ball science stream of total of 50, where 15 are black and 35 are white. A box of chopstick and 12 thin stick. For the producer, we have a kit that consists in 5 structures where we have two realistic length, double, triple, graphene, and graphene. For the construction of this structure, we shall consider that the charcoal only has 4 links and hydrogen only 1 anymore. Remember that charcoal is color black and hydrogen is white. For the construction of the simple structure, we also have to consider the recon with 4 links. For the double, it should count 5 link having precaution that not a single charcoal will stay with more than 4 or less than the same liquid hydrogen. The triple bond must count with 6 links respectively, with the explanation give results about charcoal and hydrogen. Now we proceed with the graphene. In the kit is represented by hexagons, where we represent it with 6 of these. Lastly, we have the graphene, which consists of the hexagons but with floors, and it will we represent its 3 floors with 4 hexagons in total. In the sixth figure, we can see a diamond sustained by a quadratic structure. In such way that we observe from different positions, it looks like hexagon. Seventh figure, it seeks to resemble the structure of a soccer ball because this have hexagonal form, where we realize a circular form. Eighth figure, like in previous figures, it's noted that it's conformed by hexagon that along of 5 or 6 hexagons along this.
A chemical bond is the physical interaction responsible for the interactions between atoms, molecules, and ions, which has stability in the atomic and polyatomic compounds. The carbon-hydrogen bond represents BCH. It's a simple covalent bond between a carbon atom and another one of hydrogen that is mainly found in organic compounds, in which is very abundant. A carbon-carbon bond is a covalent bond between two carbon atoms in an organic compound or carbon allotrope. The most common form is the simple bond composed of two electrons, one of each of the two atoms. Graphene has been defined as infinite alternating polycyclic aromatic hydrocarbon rings of only 6 carbon atoms, and graphite carbon atoms have a front of 3 covalent bonds in the same plane and an angle of 120 degrees.
Analysis of results. However, there are three types of chemical bonds in this lab to focus on covalent bonds, and we found that it has three types of couples that are single, double, and triple, in which the single will compare a pair of electrons, in the double 2 pairs of electrons, and in the triple 3 pairs of electrons, each representing a parallel line. We also obtain that the carbon has 4 electrons of valence and the hydrogen 1 to get fulfill the law of the octet. Conclusions. First, we can conclude that the bonds occur to reach the stable octet, following the laws of Lewis, which tells us that the whole atom tends to complete its more stable configuration. Second, we can conclude that a covalent bond is the process in which the valence electrons of atoms are shared to reach the log of octet. Third, we can conclude that there are three types of covalent bonds: single, double, and triple, and each of these pairs are represented by parallel lines. Fourth, we can conclude that the carbon and hydrogen atoms each contain or have 4 and 1 electron of valence respectively. 5. Hydrogen is able to achieve its stability when it has 2 electrons with a simple covalent bond. Hydrogen is an exception of the octet law.